Hello everyone, our next set of directions for 25 through 30 say to solve for the indicated segments. And so just like we had angle relationships formed in circles whenever we had two chords, we also have segment relationships. And so we talked about making sure to look where these two chords intersect. So these two chords intersect on the inside of the circle. And so we learned a theorem that said that the piece times the piece of each chord is going to be equal to that product to the piece times the piece. So we said piece times piece of each segment is going to be congruent. Piece times the piece. And so when we highlight that, make sure that you're doing the pink pieces times each other and the blue pieces times each other as well. And so that is going to be 3 times 14. That product should be equal to whatever 12 times x is. And we know 12 times x is 12x, and then 3 times 14. When I do 3 times 14, I'm going to end up dividing that 42. I'm going to divide that by 12. That is going to give me, for x, that is going to give me 3.5. So that segment should be equal to 3.5. And again, we pay attention to where are those circles intersecting, where those chords intersecting on that circle. Okay, so what do we know about this next piece? We've got a secant intersecting a secant on the outside of the circle. And so since they intersect on the outside, we learned a theorem that says the outside times that whole thing is going to be equal to the outside times the whole. So outside times whole equals outside times whole. So we're going to look individually at each piece. So what is the outside of this one? 9. It's going to be 9 times that whole thing. Well, what is that whole thing? It's going to be 9 plus 11, which is going to give me 20. So 9 times 20 should be equal to 10 is the outside times that whole thing. Well, what is the whole thing? The whole thing is going to be the expression 10 plus x. So we're going to multiply that by the whole thing, which is going to be 10 plus x. So we end up using some distributive property here. This becomes 100 plus 10x. Don't forget to distribute, which is what I just wrote. Don't forget to distribute that 10 to both of those things. That's 100 plus 10x equals 180. 9 times 20 is 180. And so when we solve for x, we get 80 equals 10x. And so x should be equal to 8. You can go back and check it. 10 times 18 is going to be the same product as 9 times 20. So both of those would be 180 degrees. All right, number 27. I have a secant line intersecting a tangent line. And so this appears to be different, but it's not. This is the same theorem. Outside times whole equals outside times whole. Outside times whole equals outside times whole. Only thing that looks a little bit weird is that let's break it down. What is the outside and the whole of this one? This is 8. So it's going to be 8 times that whole thing. 8 times, what is that? Going to be 14 plus 8 is 22. So 8 times 22 should be equal to the outside of the other one, which is x. But what is the whole thing? It's also x. So not only is that x the outside, it's also the whole, which gives me x squared. What is 8 times 22? 8 times 22, I believe, is 176, but hold on. Yeah, that is 176 degrees. That's what x squared is, so we want the square root of 176. That is going to give me about, I'm going to change this to approximately 13.3 if we rounded it to the nearest tenth. All right, so a few more of those. You just have to look at where they intersect. Again, we've got a very similar problem on this next one. We've got a tangent line and a secant line intersecting. So outside times whole equals outside times whole. The outside is 4. So outside times, I'm just going to abbreviate it, times whole equals outside in yellow times whole. So the yellow is going to be both 6, and the whole is also going to be 6. So 6 times 6 is going to be equal to the outside, which is 4, times the whole thing. That is going to be an expression of 4 plus x. That's the whole expression. So 4 times 4 plus x. Distributive property, make sure that you distribute the 4 to both of those pieces. That equals 36. So 4x equals 20, and so x should be 5. X is 5. Outside times whole equals outside times whole. Same thing on this next problem. The only difference is that both of these are secant. So we have an outside and we have a whole. And so we're going to do outside times whole equals outside times whole. Outside times whole. So that's going to be in yellow. That's going to be 9 times 9 plus 5. What is 9 plus 5? 9 plus 5 is 14. So 9 times 14 is going to be equal to 7 times that whole thing, which is going to be x plus 7 as an expression. So that's going to be 7 times x plus 7. And so then we just distribute. That would be 7x plus 49 equals 9 times 14. 9 times 14 is 126. And then we can subtract 49 from both sides. We get 7x equals 77. So what is x? X is going to be 11. All right, same thing on this last one. I'm just going to do an arrow pointing to here. It's the same formula. Outside times whole equals outside times whole. And so we've got 8 is on the outside of the yellow piece. What's the whole thing? What is 8 plus 19? That's going to give me 27. So it's going to be 8 times 27. Should be equal to 9 as the outside times the whole thing is going to be an expression of 9 plus x. So it's going to be 9 times 9 plus x. And again, we just distribute. So that's going to be 8 times 27, which is a big number. It's 216 equals 81 plus 9x. So I'm going to do 216 minus 81 and then divided by 9. That is going to give me that x is 15. So we had, write out my steps a little bit right there. That is going to be 216 minus 81 gave me 135. So this was 135 equals 9x. And then we just divided by 9 on both sides. And we got x equals 15. So that is our problems that involve finding missing segments in circles.